So to start, I just want to walk you through the version of the circuit that we're going to be doing today. Um, it's all based off of slash inspired by one of Big Clive's videos. So it'll be the first thing I link in the description. And I'd really recommend, if you're interested in this and you're thinking that you want to do it and you're a beginner like me, I'd definitely go check out his video. That you'll see the link in the description. Just because it's a really short video, it's really good, and you can just have it all explained to you by an actual pro rather than copying me, who's just an amateur copying him and learning the hard way along the way. So anyway, it's a super simple circuit. The version that we're going to be doing today is coming off of a 5 volt 1 amp supply because they're everywhere and they're awesome. So the supply just comes out, splits off in parallel. On the one side goes to some LEDs that we're going to be using different LEDs, so they're going to all be resisted separately and in parallel. So I can't tell you exactly the ohm values, but I'll get to that in a second. So anyway, splits off in parallel. One side goes to some LEDs, the other side just comes down to a larger value resistor. In this case, I used a 15K. And then that comes down to an LDR, otherwise known as a photoresistor. The components are very easy to find. And then on the other side of the LEDs, the negatives are all common, and they come into the collector of a 2N3904 transistor. You can use any NPN general purpose transistor. Oh my god, this camera is already pissing me off. We're just getting started. I need a new recording setup. Anyway, like I was trying to say, the transistor, you can use any general purpose, NPN transistor. They're typically rated, those are typically rated like around, a couple hundred milliamp, 500 tops. So that's something to keep in mind depending on how many LEDs you're going to be using and what you're going to be running them at. But yeah, like I said before, all the components, they're super easy. You can find them anywhere. Actually, I even went to like the dollar store because I had ordered some of these. I didn't have any, and I didn't want to wait, so I went to the dollar store and pulled a couple out of night lights. So I mean, you can find them anywhere. But yeah. So basically, I kind of lost track of how much I explained in the last clip because I ran out of space. The camera just cut out. But you just the LEDs, the negative are common together. They come in the collector of this transistor, and then the base is spliced over and joined right where the resistor and the LDR are joined, and then the emitter just comes down and it's common with the other side of the LDR. So it's a super simple circuit, and it would actually be even simpler if you were only using the one type of LED. You could just basically get away with only using one resistor. I can't, like I said before, I can't tell you exactly what ohm value resistors to use because two reasons. One, there's a little bit of like an interplay between these resistor values here. The resistor value that you have here is going to determine how much gets put on this transistor, and then that will determine how much is going through over here. So if you have more resistance over here, will result in needing less resistance over here. Having a lower resistor value here is going to require a little bit bigger resistor values over here. That's one reason, and then also the other reason is I just don't know what LEDs you're going to be using. And I just wanted to show you real quick how you could figure that out because it's super easy. So Ohm's law is just, basically to figure out your resistor, you're just taking the voltage of your supply, subtracting the forward voltage of your LED, which is just the voltage the LED is running at whichever level current you have it running at, and that's over that level of current that it's running at, expressed in amps, which is important to remember. And then the beauty is that these values are all given for you. You just go look them up. 99 times out of 100, wherever you buy your LED, you go look up and they'll have a whole bunch of handy info for you. It'll be like typical forward voltage, forward voltage at typical current levels and stuff like that, and they'll give you the max current levels, usually around 20 milliamps for just running steady, if you're not pulsing it or anything. But and yeah, so you just go look it up and you plug in the numbers that you want there. So you figure out, look up whatever the voltage is going to be at whatever the current, and remember to express that in amps. So a typical example is, if like say a green or a blue or something like that, or purple LEDs, anything but the reds and oranges basically, those are typically lower around the 2 volt area. But here's an example: 5 volt supply minus the 3.5 volts over the 20 milliamp gives you around 70 ohms. And look for, the resistor values you find, you'll probably find a 75 ohm, and that would be perfect. So that's all quite simple. So originally this video started off with footage of me building a completely different version of the same circuit, but then this one became such an epic adventure that I just realized it'd be better as a whole separate video. So coming up here, you're going to hear me mention uh, that other footage, and it's no longer in this video, and I just didn't want you to be confused. So here we go. Here's the original project as it unfolded. And so here's a different version of the circuit. It's exactly the same as the other one that we did. I just, I didn't plan the layout or anything like that. I was just winging it, so it looks a little different, but it's the exact same thing. Positives are over here, the negatives are over here. The supply to the circuit comes in here, and it's just jumped with a little copper jumper over here to where it goes in parallel to both of these resistors. The different value or size resistors, it's just whatever I had, whatever I happen to have here. If I would have had another, an appropriate value 1/2 watt resistor, I would have used that as well, just because I think over time this will stay looking nicer. Not that this circuit's really running very much current through it anyway, so the resistors will probably stay looking fine. But that's all that's about. It really makes, this is all so simple that, it wouldn't have mattered. I just didn't happen to have 1/2 watt carbon film resistors in anywhere near the right value. So I just used a 1/4 watt. So anyway, the supply comes in here in parallel to both of these, splits in parallel to both these resistors. Through here, this is just going out to the LED, or the LEDs that will be driven off this. And then the negative comes in, goes in the collector here of the transistor. It's a, just any NPN transistor. This is a 2N3904. And then, so it comes in the collector here, and then what is that? I always get confused on the different pin outs of the transistors. Is it the emitter? Or that might just be what the FET ones are called. But anyway, you know what I'm talking about. Comes out down here to the negative, and then the base, or the gate, it just comes out and it splices in right here to where this other resistor came down to the LDR, and it's just spliced in right there where the resistor and the LDR are joined, and then that just goes down and to the negative as well, and that's common with the emitter of the transistor. So that all it is just like on Big Clive's video. The photoresistor will, depending on the light level, when it's appropriate, as the resistance changes, it'll eventually put enough on the transistor to switch, and then we'll power this. So it's so simple. It's the exact same thing as what we had there. It just looks a little different because of it's just a little different version. I'm going to do a few versions of these, which is what I want to show you. I got some holes I made in the PCB just for I made some spacers, and all those are just little pieces of nylon rod that I put pilot holes in for some little 256 button screws. So what I want to do real quick while I got this in the vise is just sort of mark off where I'm doing this all one-handed and holding my phone, but I just want to give myself a rough sort of line of where I need to trim. And if I can sneak my hand in this way. Oh, that's rough, but I won't. I'll cut it neater. That's the best I'll do one-handed holding a phone. But yeah, so made some spacers. I'm gonna trim that up, and then that's. I wanted to just show you real quick about the cases. I'm doing a few versions of this, so I'll be putting them in different things for different applications, different areas, like indoor, outdoor, whatever. But like some of the things I thought were cool when I was looking for different casings was like I have these. They're just little mini, tiny little storage containers that I used all over the place, just to help, you know, hold little tiny components for different, you know, parts that I'm making or whatever. Like, just to, you know how you always have so many different things you need to keep together. So those are handy, and I thought that would be really cool because it's so tiny. You could, you know, build the actual module into one of those with the wires coming out and the connectors, you know, greased. You could use resin to sort of seal this and make it totally waterproof. If you want to, you could even use the little coin lithium cells, and you know, have a couple pods of cells in parallel. You know, and if you could find a way to make them sort of, you know, a little waterproof yet accessible to change cells or whatever. I don't know. There's a lot of different ways you could do it, but like I was looking at just different little cases. This was just a case for some cutting bits. I might try to put one in there. You know, and some of these things, you could even, if you found the right case, you could put a solar panel in, and then have the solar panel charge you know, a polymer sack. And this was cool. I think I'm going to use this for one of the indoor versions. It'd be a nightmare to seal for outdoor, but I just thought it was so cool. This was just a, you know, bob for like felt polishing wheel case, but I just noticed I hadn't when I got it, but it's in an old audio cassette tape. I just thought that was so cool to see something repurposed like that, like right on. You know what I mean? Instead of just ending up on a landfill somewhere, all these audio cassette tapes. You know, it's just cool. You don't see that very much. You don't see like blatant repurposing of, you know, commercial packaging materials and stuff. So it's pretty freaking cool. I thought that was neat. Anyway, that's just, you know, one of the cases for an old audio cassette. Somebody got a deal on some other packaging, but that's cool though. So yeah, I've got a pile of those little cases here, which would be one cool way to do it. And these would be something that I could string out on my balcony, because they wouldn't be directly exposed to the rain or anything. It would be moisture and stuff. But I'm kind of accommodating that in what I think I'm going to do. Although I don't know if I'm actually going to do that. I might just do an indoor one, because kind of the first thing I wanted to do was just make some ambient, like some lighting that came on my parts cabinets over here. Just kind of automatically once it got dark. Just a real low level light just for aesthetics. But I'm not sure. I might end up doing the patio lights with this, just because it kind of seems like I have. It's kind of the perfect little cases, and I don't know, it's a cool idea. And what I would do was, the whole idea with the spacers is so that, you know, I'll trim the circuit board to mount in here, and the spacers will keep it lifted up a little bit. But it'll actually be upside down, so the clear side is up, and the spacers will keep it up off the bottom, so that I can tuck a tiny little moisture silica gel packet underneath the PCB and seal that inside with it, because it won't be getting rained on directly. But where I live, and you know what, even for an indoor version, I think I want to do that, because where I'm at, it is so humid, even like in the wintertime. The air is just wet all the time, and like I've actually had that cause problems before. So those are the baubles that I rigged up with LEDs on one of my workbenches. And I was, oh, hold up a second. Turn the parts cabinets on here. And I was thinking it might be cool to hook one of these into this, so that it kind of comes on with the light from outside, and I could kind of mount it on the side of the parts cabinet there, where the light from the patio kind of comes in, and they would just automatically turn themselves on. That would be kind of cool. But yeah, I guess it's not too distracting. I can leave those on. Yeah, so there's the circuit. um, that I've trimmed it up, and it's sitting inside the base there, and you can see the positive being jumped over. It's just bridged to the resistors. A lot of the stuff where I bridged it, I just did on the underside, so it wasn't so there's more room to work, and it's cleaner. And then you can see it. I've sort of trimmed it, put those spacers on. There's where the spots where they're bridged underneath. The spacers just kind of screwed in from the top there, and that was just sitting on one of those silica packs. So that'll be kind of the idea there, is that will mount in there. So I just gotta kind of figure out exactly how I'm gonna bring the wire out and put it together, and just kind of glue that up and waterproof it. Put some JSTs on, and then that'll be that basically. And then I'll just decide what to do for the lighting after the fact. I kind of just have a general purpose resistor on there that I can put more resistance for different things depending on what I'm gonna do. So yeah, anyway, let's get that done. So I ended up not being able to fit the silica pack in there. I could have, but it wouldn't have been worth the amount of work. I would have had to repack it in a different little package without as much, or just empty some of the salts anyway. But yeah, so it wouldn't have been worth it. But it was a novel idea. I mean, this is gonna be the indoor, so it won't matter. It's all sealed, so the air that's in there now is the air that's in there. See, I've got it inside, all mounted on the spacers, and with some JST connections for the supply and the LEDs. So it's really modular. I can just bring this around, tack it up, and then it can feed whatever off just any 5-volt power supply. Basically getting the wire out was the hardest part. Like, what I did was I just tightened it together. Well, like, just took the container, tightened it super tight, took the Dremel, made a little divot right where I wanted my hole, and drilled a 5/32 hole in there. And then I had to, I cut off the wires right there where it's all heat shrunk. You can see there's some clear heat shrink over top of each connection, and then like each one I even had the matching color shrink, so that was a bonus. But yeah, I just basically pushed the wires back up inside here with this inside of it up into this clear top part, and tightened it in, and then got the wires back out of the hole afterwards, and then reconnected it. Was how I had to do that. Kind of like building one of those model ships in the bottom. But it's cool because now it's all sealed up, and it's ready to go. Yeah, it's turned out quite nice. So yeah, there's that, and JST'd up. I put a little dot there so I'd always know what was the negative. Yeah, so now I just need to make the LED part, and then we're set. So for the LED part, it's gonna be in another one of these little cases. So basically what I did is I just took a Lego block and just drilled it out for the LEDs, sanded the crap out of it, and shaped it so that I could just press fit and just shove it inside this container. So there you can see how that'll kind of hold the LEDs in. And the idea is sort of, I'm gonna make like a spectrum of the LED colors. So yeah, basically, and like I didn't want to heat shrink the resistors. So I'm just alternating which side the leads come out of, so that way, because the negatives are shrunk, like have heat shrink on them, and then I'll just use probably hot glue to just cover up those positive pins, because I need to secure those in there anyway. So that pattern will take care of just keeping those from making contacts. Like I'll cover them in glue. But anyway, yeah, the LED spectrum, it's gonna start, from one side. It's gonna be like pink, purple, blue, green, yellow, orange, red. They all have crazy different, well, not crazy, but they have different forward voltages. So on top of like just the sort of one resistor that I have on the circuit coming out where the LEDs get fed, I just have another bunch of resistors kind of running the gambit. The warm colors, reds and yellows, would have to be resistored more. But then I kind of just picked out low value resistors for the green, blue, pink. Pink is in the order. It would be like the red you'd have to resistor the most, yellow, orange, and then green you pretty much might not even have to put another resistor, but just to sort of hopefully keep the brightness kind of like even across them, I'll put at least a little bit of resistance on that. Blue can resistor it a little bit. It's a little bit lower voltage than the green. The pink is exact same as the blue. I never used to understand that, but then in one of Big Clive's videos he said that I'm pretty sure the pink is just actually a blue LED, but it has a different coating that makes it shine pink, and that makes a lot more sense now, because I was always wondering why that is. Purple would be the next under, then yeah, that's so. Just because the different voltages, I'm just gonna tack a couple like resistors to tweak, and then those will all be their main resistors already on the circuit, but yeah, so it's won't be easy on that one. Make something up. In the bottom, I did up using standoff spacers, brass standoff spacers, 632 brass knurled nuts, and little tiny brass tubing and a rivet for where the wire comes out, just to kind of have, it'll have a nice base, but kind of not just for looks, because it'll keep this one sort of raised up above the other one with the module in it, so the LEDs don't interfere with the ambient light sensing, and it doesn't shut itself off. So yeah, that get those in there, and then it'll be a wrap. So there's the LEDs all mounted in with their little resistors to tweak them. So now I just have to fish out all that excess and trim it up, common them together, and run the wire and assemble it. So freaking beyond frustrating. I got that all in, and I had to just rip it all out and destroy it, because only half of the LED array lit. Basically everything from the middle there over the green, the yellow, orange, and red all lit, but the pink, purple, blue didn't light. And it's really freaking just boggling my mind, because I mean, one, it's not rocket science, it's just hooking up some LEDs in parallel, and also it's just like, it's a freaking pain in the ass, because see, like, I don't really understand what actually happened, because I tested all the LEDs as I was putting them in, to make sure like the connections were good themselves, and I tested it after I pulled it out, and the splices were all good. There wasn't like a bad joint or something. It was just a cold joint or something. And it can't just be something stupid like, oh, there's too much resistance on some of those colors, or it wasn't enough in the fry, because of which LEDs lit. If you think about it, the green lit, and and then the red, yellow, and orange light. Well, those are the highest and the lowest forward voltages of the array. So if I just had the resistance wrong, do you know what I mean? Like if let's say I had not enough resistance, if I just was, because I just kind of went off from memory what I knew the forward voltages of these were. But if you know, say I had that wrong, well, if I didn't have enough resistance on those other colors, well, then the other ones would have fried too. Do you know what I'm saying? Like, because the lowest and the highest lit fine, and the ones in between didn't, and I resisted them proportionally. So like the green barely has any extra resistance other than the one they all share. It's got like 5.5 ohm resistor on it, whereas the red's got like a 60 ohm resistor added to it because it needs less juice going through it. So if the red and the yellow lit fine and the green lit fine, but the blue and the purple, which are in between those in terms of forward voltage, didn't light, then it can't just be a matter of like, oh, I'm using improper resistors or something like that, right? I didn't nuke the LEDs, they're fine, I tested that. So it's like really something that is either a problem with my understanding or there's a thing going on here that I'm not aware of. Like, it's not that my understanding is wrong, but there's something else happening, and I'm thinking like, you know, I know there's resistance with thin wire, right? And especially running lots of extra wire creates resistance. You got to be careful how you loop it. You can't pinch wires. You know, so like I know there's more. Like I don't have a grip on a lot of this stuff yet, so it's just gonna be a big process of elimination now. What I'm gonna have to do. It's just weird because the obvious things, it's not that. So what I'm gonna have to do is rebuild this on a piece of PCB just so I can find out what's happening and why, you know, some of those LEDs don't want to power. And then once, you know, that'll let me figure it out without having to worry about it being something stupid like splices or pinched wires or whatever. Because I could have just, you know, damaged one of the circuits when I was putting it in. You know, broke a wire or something like that. This is like 28 gauge wire, because it just all had to be cram food in here. And there was like, you know, you can see the clearance there is nothing at all, considering there's resistors and stuff. So it was all coiled up pretty packed in there. So I'll redo it on the PCB and get it working and figure out what's up. So I've got the thing redone, ditched all the splices and redone with the PCB. And actually I'll say that I'm glad for the epic fail the first time, because the PCB is a lot better. It's just a lot cleaner. It's gonna look a lot nicer, and just easier to actually fit. Let's see if I can unscrew this one-handed. Maybe not. Yep, I got her. Get out of there. Okay. So here's yeah. So it's just a bunch of jumpers. It's just way cleaner this way, way less, you know, nonsense. Yeah. So, you know, and that's just basically like tracks on a circuit board. It's just positive and negatives because it's in parallel. The one problem is though, is it still doesn't fucking work. So, and the exact same LEDs are lighting up, and it's the same mind boggle. So I think the obvious, I mean, if you're looking at this, like, you might think, oh, well, some of those joints look kind of cloudy and ugly. It's just because they had Sharpie on them. There's continuity, the connections are all good. It's the exact same, like, nothing that obvious as last time. So I think the obvious lesson to be learned here is, see what I ran that to test it. I could have showed you. I should have left it on, just off of a power bank, because it's a 5-volt supply. So I tacked the same resistor that I had coming right off of the feed from the module itself, um, on there. And I think that's the obvious thing, right? The lesson here is that because these are all different LEDs with different forward voltages, I need to ditch this resistor, because it should, instead they should just all be grabbing their supply straight from the supply with their own resistors. I'm pretty sure. I mean, I don't know, right? I'm just learning this. That's exactly what this is. So no one's gonna learn this for me. So yeah, I'm pretty sure that's the problem, which is a pretty huge pain in the ass, I'm not gonna lie, because not only do I have to redo all this, like take all that off, desolder it, and redo it with all their own resistors on, but also, of course, there's already that resistor in here in this module, which is actually threaded together with that inside of it, and the wires protruding out a hole and all sealed up. So yeah, and that's the only photoresistor I have currently. I borrowed it from a dude at work, and I got more coming, but looks like I'm gonna have to smash that fucker open and take that resistor off of the line that's going out to this, so that I can resistor all these independently. So yeah, FML, epic fail number 2. And I'll be back with the third version of this in the exact same way, and hopefully it works this time. Haha, success. The PCB proved to be the ticket to get her working, to just in the game of process of elimination when my immature ass can't really tell what's going on. It just helped. And what you're looking at there is just the negative. It's just a bunch of jumpers sneaking around grabbing the negatives, and then a bunch of quarter watt resistors that I had to really play with the values to figure out what was going on and why the purple wasn't lighting and whatnot. You can see all those resistors just kind of all common together up there where it's being grabbed. Those are just some wires that I had so that when I plug her in here. Sorry guys, give me 2 seconds. Got her sideways here. There we go. So then you can see that now she's all good. And it actually is really cool. It does give, like, it lights a perfect, let's see if I can show you this. It lights like, probably won't show up on camera, but it lights a perfect rainbow, like from red, orange, yellow, green, blue, purple, and then like an indigo. So it's pretty sick. Yeah, that it definitely ended up. So now I can, get her all put together here again. It definitely ended up, it was something. I definitely stumbled upon a thing here, because like the ohm values that I ended up needing to get the kinks worked out of that, like the numbers that gives you is kind of wonky. Like you'd think that would be running them way too high. So clearly, I mean, crappy connections could have had a lot to do with that, because it would create more resistance. But still, I got some learning to do, clearly. But at the end of the day, she's fucking working, and that's what counts. So let's get her together. So that's all wired up, and that's good to go. But now, of course, have to get back in here and take this resistor off of the supply, because in Big Clive's video, he has a resistor there because he's driving a bunch of the same LEDs that are all in parallel, and I should have known and just learned the hard way that I don't need that one there, and now it's stuck in there. So now, with the circuit board liberated from the other module there, um, you can see that I've just popped off that resistor that shouldn't have been there, and then just kind of blobbed over the solder and just bridged the two pads there, so that now this module is just grabbing its supply like raw, you know what I mean, and then all the resistors or the LEDs are resisted independently, which it should have been. So because, you know, basically that was kind of like a lesson of you can't resistor bargain unless the LEDs have the same or nearly the same forward voltage. So put that to the test, and that's a true story. And so I've hooked this back up, you know, with that fixed, and hooked all the wires back up except for I left the negative from this unconnected just for the sake of showing you this. So I'm gonna just kind of tilt this over so you can get a better view of it. And so now that this negative is unconnected, I can bypass the circuit here and just go in straight to the negative of the power source here, and you can see that you know, it's all good. This all checks out. It's all working. But now watch what happens when we go into our circuit here. I'm going to connect this, and at first we don't get anything happening, which is right because this is what the circuit does. But now watch when I block the light. We're getting the same damn lights that we got before. How is that even freaking, you know what I mean? We've never hooked up to this yet. I simulated this by hooking up the same resistor it had, the erroneous resistor, which it should have never had. This is the first time actually being into this, and like, go figure, the irony is like a law of the universe, or you know what I mean? Like, it's the exact same shit's happening. And interesting that, you see how it climbs as I block the light? It climbs, the LEDs climb with the resistance that's being, you know, the more that's being put on the transistor. More switching, which makes me wonder if, see, initially, I didn't think that any of this stuff over here, let me get something pointy. So over here, whoops, now I'm bumping stuff around. You know, where the positive comes in, this is all just, I didn't think that, you know, here's what's the supply out to our LED module, the yellow wire here, and the red is from the supply, but the positive coming in. I wouldn't have thought that anything here would have been affected by anything back here, this resistor, because it's essentially grabbing it with it or before it, right, in parallel. So really the only way that anything over here can affect what's going on out here on our yellow wire, which is, you know, the only way that anything back here can affect that is when it comes in the negative here at the collector of this NPN transistor. So right away my thoughts start, you know, going, okay, well, there's something about the transistor. Most of these NPNs are the ones that I use are only rated 200 milliamps. We're within that, so it's not that. You know, there are other things with transistors than my limited experience trying to use these bastards. I've run into a few wonky things where, like, if the signal voltage is lower, I don't remember the details to be honest with you, but I know there's some wonky things where you have to switch and use an N-channel MOSFET instead if the signal is either higher or lower relative to one of the other pins. I forget what it is, but I don't think we're running into that here, to be honest with you. So I'm curious if maybe I'm wrong in assuming that this has no effect on this. Maybe if I tinker with this resistor value, we can get more. Maybe it's not, being driven, like the full voltage of the circuit isn't being pumped through that because of this. I don't know. I didn't think that was the case. I thought this strictly handled the sensitivity of this and how much it put on the switching on the transistor. But now there's a whole new set of things to process of elimination. So basically it involves just possibly changing transistors or messing with this. Because for some reason, like we see here, when we should be, we know it's not a problem of the actual supply of, or anything stupid, because when I hook it up right to the supply, we're good. So more to troubleshoot. Oh, and it's not, I know another thing that people might say if they see this is that just these power banks aren't most reliable, well, especially cheap ones like this. But at putting out like a very small current, a lot of them get wonky or simply don't work. But I mean, I kind of already thought of that. I tried it with just like USB, just straight out of the, getting rid of the power bank, and it doesn't change anything. We're still getting the same thing going on, where somehow going through the circuit is not quite. Oh, that's interesting. A little bit of current is bleeding through there. See, it just goes to show you, even when shit's just going totally wrong, which is kind of the name of the game at the beginning, you're learning stuff. And look at that. Can you see that on camera? The purple rather, dye is actually, and same with the pink. You can't see that on camera. Maybe you can. It's getting a little bit more. So, there might be something to that. Not going through the power bank here now, it's probably a more reliable voltage coming to the circuit. So it is something with the voltage that's being supplied to the, I don't know. I obviously don't know. But hey, we're getting to the bottom of her anyway by the time this is done. I only have, the crappy thing is being limited with only having a couple of these. I don't have like sort of enough of other transistors and any the right parts, so I may have to just complete this one in a more doable sort of like one, you only using one type of LED or very similar forward voltages anyway, sort of make a different module for this particular one, and then I might have to just rebuild this exact thing on circuit board, not in these modules, and just plain old get to the bottom of this and do all the learning that's gonna come with this. Yeah, there you can definitely see those are getting a little bit more now that we're plugged into the wall. So yeah, nothing new from, I just wanted to show that gotta mess with this here now and just continue this process of kind of tinkering, and it's good learning all about this stuff anyway. So totally got it figured out, and I was wrong about what I was wondering earlier. All this stuff back here in the resistor, this half watt resistor, it doesn't just affect the sensitivity of the photoresistor and the switching. Like there's a direct relationship between how much is getting put on the transistor and how much we're getting over here, and that's basically the crux of what I wasn't getting. And so big time leveled up on transistors and also obviously how they work in conjunction with this stuff. Resistance basically is all that is. But so yeah, I basically just had to, all it consisted of was just toying, finding the right balance of these resistor values, so that all this stuff was getting the right amounts to light everything up. and basically I had to drop all the way down to a 15K resistor over there, and get down to around 10K on the on a 5 volt supply anyway. And you're looking at, that's about the area where um, you've gone to, like, if you go with too much, or too much resistance, and you're not going to get all this stuff to light up even when it switches on. And if you go with not enough resistance, it will just always be on no matter what, regardless of the ambient lighting. Basically, like you'll have ruined the functionality by having it too sensitive or whatever. So it was basically finding the sweet spots. But I had sort of a misunderstanding exactly of, I was thinking of transistors as like all or nothing. Either there's enough on it to switch or not. But really, the amount getting put on that was crucial to what was going on over here. So yeah, it's really cool that basically got this slicked. So just got to get this back inside a module again, and then this will be ready to go as probably a cool stand for something like that. I think it's so cool how it climbs, like with the, it's pretty neat. That's pretty awesome. And yeah, like one thing I do have to do before I finish this is just stick a multimeter on here, just see exactly what I got on this side, just to cement, make sure I fully, learned the lessons to be learned here. But yeah, good news anyway. So even though there's no way that this camera is going to pick this up, I just want to try to do a little more justice to this. It'll give me a chance also. I wanted to point out before, just to get you a better look at the LED array. It's actually not a true green. It's kind of almost like a bin 2 5mm green, if they even call it that at that size, but it's like an aqua teal color. But yeah, it's quite nice. I'll see if I can get this. We'll lose the brightness, but maybe you can actually see the colors anyway, to get a look at what this looks like, because it just wasn't showing up before. But just the colors in there are just remarkable. I kind of have no choice but to lose all the brightness just so you can actually see what I'm seeing here in person. But it's just unbelievable how crazy cool this looks. There's just this chaotic rainbow, of like colors in there. Almost looks like, it looks like outer space or something in there. It's freaking nuts. But yeah, so that's gonna turn out really good. I'm just gonna get that all cleaned up and back in a module or something. Cleaned up the circuit. Didn't need those. I could just kind of common the positives together. It was a little neater that way. And then just touched up everything had gotten kind of hacked up from taking it apart so much. Got the wires through. So now I just got to hot glue this, and then good. Make sure I got this sitting in a good spot. Just gonna tack it in place to begin with. careful, buddy. I'm trying to solder and you're bumping me. I need steady hands, man. What are you trying to do? Sabotage me? Careful, careful. There's bad stuff up here. You're trying to sabotage me, aren't you? You want me to have bad joints. Well, it's working. Oh, sweet. That's a wrap. So there you can see, got the modules all finished up. The reason for the clear shrink over top of everything and braiding the wire here was to sort of control where these are going to bend, so that they'll bend here and not bend at the joints. So that this can just be tacked up anywhere and just hooked up to any 5-volt supply. You know, and then just, yeah, pretty slick. And you can see this one. So, basically, you know, as the light level dips, you can come on more. And, yeah, it's, pretty slick. Yeah, pretty cool. Thanks for checking it out, guys.